Hello everyone. In this video, we are going to see these topics from nano communications. So first, we'll be starting with the block diagram of basic communication system, and then we'll see what do we mean by modulation and what is the need for doing this modulation, and what are the basic types of modulation depending on the characteristics of a signal. So basically, communication is the process of exchanging some information. This block diagram shows a simple communication system. There will be an information source and transmitter at the transmitting side, and there will be a receiver and the destination at the receiver side. This channel is the media which will be transmitting the signal from transmitter to receiver. And this channel can be either wired channel or wireless channel. So in the channel, due to noise, there might be some distortions. So the transmitted signal along with the noise will be received at the receiver side. So here the main function of transmitter is, so it will basically converts this information source into a signal which is suitable to transmit over the channel. So this information can be of any type. It can be an audio signal or image signal or anything. So the function of this transmitter is that it will convert this information into a signal that can be easily transmitted over the channel. So at the transmitter side, we use encoding, modulation, all these processes. And at the receiver side, the exact opposite operations will be used. That is decoding and demodulation operations. So coming to the modulation, before seeing various modulation techniques, first we'll see what does modulation mean. So modulation is basically a process of mixing a signal with a sinusoid to produce a new signal. The process of mixing a signal with a sinusoid to produce a new signal. This new signal will have certain benefits or advantages over the unmodulated signal. So basically, mixing of low frequency signal with high frequency carrier is called modulation. So if we consider voice signal, so its range is around 300 Hertz to 3.3 kilohertz. So these signals are of very low frequencies. Whenever we transmit a low frequency signal directly, they cannot be transmitted for longer distances because these low frequency signals will be easily attenuated. They can be easily attenuated. So hence, we cannot transmit the low frequency signals over long distances. So what we do is, by using this modulation, we mix this low frequency signal with a high frequency carrier signal so that the resultant modulated signal will be of higher frequency. So as we are translating the low frequency signal to high frequency signal, now these modulated signals can be transmitted for longer distances. So as low frequency signals cannot be transmitted for longer distances, we modified the carrier with respect to the modulating signal. So in modulation process, there are basically three signals. The first one is modulating signal, that is the message signal which we need to transmit, and the carrier signal which is a high frequency signal. So it is called carrier because the signal will carry the message signal for longer distances. So the name implies that it will carry the modulating signal, that is the low frequency modulating or message signal, for longer distances. And the modulated signal is nothing but the resultant signal which is obtained after the modulation process. So if we see a practical example for this case, so let us consider two cases. I am throwing a piece of paper. In the first case, I will throw a piece of paper directly, and in the second case, I will wrap this paper onto a stone and then I will throw this. So in both these cases, in first case, I will throw the paper directly, and in the second case, I will grab the paper onto a stone and throw it. So can you tell me which case the paper will travel for longer distance? In the second case, the paper will travel for longer distance. Why? Because in the first case, the simple paper cannot travel for longer distances. And in the second case, we are using the help of a stone so that it can be traveled for longer distances. So in the modulation process, this piece of paper can be considered as the message signal or modulating signal, and the stone can be considered as the carrier signal. So basically, this stone will carry the paper for longer distances. The stone does not have any message that we require, but its main function is to carry the message for longer distances. So this is the basic modulation process. So as we have seen what does modulation mean, so now we will see the reasons for doing this modulation. So coming to the need for modulation, the first and the important reason for doing modulation is to reduce the height of an antenna. So in wireless communications, we know that there will be an antenna at the transmitting side and receiving side. So whenever we transmit a signal, it will be transmitted over the antenna and over the wireless medium, and at the receiver side, the receiving antenna will capture it and the data will be detected. So in general, the size of antenna is given by lambda by 4. So its height is around lambda by 4, where lambda is the wavelength. So for voice signals ranging from 300 Hz to 3.4 kHz, value of lambda will be, so I have taken frequency as 3 kHz. So lambda will be C by F, which is 3 into 10 power 8 by 3 into 10 cube. So lambda will be 100 kilometers. So the height of the antenna, which is lambda by 4, becomes 25 kilometers. So installing an antenna of 25 kilometers is not practically possible. So if we are transmitting a voice signal of 3 kilohertz directly, so we need to install an antenna of 25 kilometers. So instead of transmitting this low frequency signal directly, if we modulate this signal onto a higher frequency, let's say 1 megahertz, so by using carrier which is of 1 megahertz, so if we translate this 3 kilohertz signal to 1 megahertz signal, then the lambda becomes 3 into 10 power 8 by 1 into 10 power 6, which is 300 meters. So the height of antenna becomes 300 by 4, which is 75 meters. So an antenna of height 75 meters can be easily installed and is practically possible. So simply by translating this low frequency signal to high frequency, we can reduce the height of an antenna from 25 kilometers to 75 meters. So this is the main reason that we do modulation. And the other two reasons are for multiplexing, that is to transmit multiple signals simultaneously over the same communication channel. So since by using modulation we can map these the different users onto different frequency bands, they can be easily transmitted simultaneously without any interference. The third reason we go for modulation is to increase the range of communication. So this one we have already discussed earlier. So as low frequency signals cannot travel for longer distances, because these low frequency signals can be easily attenuated. So instead of transmitting these low frequency signals directly, if we increase the frequency of these signals by using modulation process, then they can be transmitted for longer distances. So the attenuation reduces with increase in frequency of the transmitted signal, and they travel longer distances. So the modulation process increases the frequency of the signal, and hence it will increase the range of communication. So till now we have seen what do we mean by modulation and the reasons the main reasons that we go for modulation. First one is to reduce the size of antenna, and second one for multiplexing purposes, and third one to increase the range of communication. Now let us see the types of modulation techniques. So first let us consider a carrier signal. So carrier signal is AC cos 2 pi fct plus pi c. Here AC is the amplitude of the carrier, and fc is the frequency of the carrier, and pi c is the phase of the carrier. So if we define the modulation technically, it is the process of varying the characteristic of a carrier signal in accordance with the message signal. So we have three different parameters for any signal. They are amplitude, frequency, and phase. So modulation is the process of varying any of these parameters in accordance with the modulating or message signal. So if we keep this frequency and phase constant and vary this amplitude with respect to the message signal, then it is called as amplitude modulation. And on the other hand, if we keep this amplitude and phase constant and vary the frequency with respect to the message signal, then it is called as frequency modulation. And if we vary the phase by keeping this amplitude and frequency constant, then it is called as phase modulation. So by varying any of these three parameters, we can define these three modulation techniques.